Hello, and thank you for taking the time to attend this presentation. My name is Allan Meek, and I'm a founder director of Group SCS, and I've been in the smoke control industry for 35 years. Today, we'll be looking at the proposed changes to BS 9991 from a smoke control perspective. BS 9991 is the code of practice for fire safety in the design, management, and use of residential buildings. It complements BS 9999, which is the code of practice for non-residential buildings. The standard gives recommendations and guidance on the design, management, and use of residential buildings in order to achieve reasonable standards of fire safety for people who are in and around them and firefighters. The standard offers a holistic approach to fire safety that can give designers more flexibility than following the prescriptive guidance in Approved Document B. 9991 provides guidance on the management of fire safety during the whole life cycle of a building. It applies to the design of new buildings and to material alterations, extensions, and material changes to the use of existing buildings. The public comment phase for the draft standard closed in October 21, and the new version is expected to be published later this year. This presentation is based on the draft standard, and it is likely that there will be further amendments based on the comments received prior to publication. Most of the changes are intended to improve the means of escape from high-rise residential buildings and to facilitate evacuation where necessary. We'll be looking at the major implications for smoke control and associated areas and offering our advice on how to plan for the new standard. So the general changes are, the first one is where a backup power supply is required for essential equipment such as firefighting lifts and smoke control systems. The proposed standard details the methods of achieving this as either a generator, an uninterruptible power supply, a UPS, or an independent high voltage supply, provided it's fed from an independent substation to that feeding the primary supply. Using a single intake with diverse routes and a life safety distribution board is no longer acceptable. In all developments where passenger lifts are installed, at least one lift should now be an evacuation lift. Access to the evacuation lift or group of lifts should be provided via a protected evacuation lift lobby. This should not connect directly with flats or storage areas or other areas of risk, for example, refuge areas. In buildings over 18 meters with multiple staircases, more than one evacuation lift is needed. Where more than one escape staircase serves a single story, the number and positioning of evacuation lifts provided should be such that if a fire affects access to any one lift, alternative lifts will remain available for use. Smoke control systems will be required to protect the lobby as well as the staircase. For extended corridor systems, an additional smoke control system may be required for the corridor, and we'll look at that in more detail later on. The current version of the Smoke Control Association Guide to Smoke Control in Apartment Buildings states that for buildings where the escape travel distance is within the Approved Document B recommendations, then the only performance criteria for a mechanical extract system is to be at least as effective as an equivalent natural ventilation system. There have been cases where CFD modeling has been used to justify the use of a mechanical system that permits smoke to enter the staircase on the basis that the code compliant system does this as well. Clearly, this is unacceptable and was not the intention of the SCA guide. In the new 9991, this is no longer permissible, and CFD modeling must demonstrate that the staircase is kept free of smoke. So the biggest change is for single stair buildings above 18 meters, where pressurization is now deemed the only approved method of smoke control for the staircase and lift lobby. Pressurization systems work by raising the pressure within the escape route relative to the fire zone to prevent smoke entering in order to allow people to escape from the building. They also provide a minimum velocity of 2 meters per second through the door between the stair and the lobby when it's held open for firefighting. They're widely regarded as offering the highest level of protection for occupants and firefighters. The most common current approach to such buildings is mechanical extract from the common lobby, which also acts as a firefighting lobby. This is no longer an acceptable alternative to pressurization. It should be noted there'll be a greatly increased level of plant to be accommodated in the building based on the current draft standard. The current standards for pressurization are also in the process of being changed, with the design of systems being covered in the new BS EN 12101 Part 13. and the equipment being covered in BS EN 12101 Part 6, which currently caters for both design and product. The draft standards have been approved and are likely to be published later this year. The new standard simplifies things a bit with less categories, and the specified pressure difference has reduced from 50 pascals to 30 pascals. The firefighting provision, however, is similar in that the open door velocity for firefighting protection remains at 2 meters per second. Achieving the open door velocity is the most onerous criteria and the one that dictates the fan and duct sizes. So there should be no significant change to the plant sizes as a result of the new standard. This illustration, taken from EN 12101 Part 13, shows a typical arrangement for a pressurized staircase with a firefighting lift and lobby. The shaded areas will be pressurized to prevent smoke from entering. There'll be separate fan sets required for the staircase and lobby, with a firefighting lift shaft also being pressurized by the lobby fan set. The fans and air intakes should ideally be located at ground floor level to prevent them becoming contaminated with smoke and recirculating it around the building. Or if this is not possible, they may be mounted on the roof. In this case, they must have two separate inlets with in-duct smoke detection and shut-off dampers arranged such that they cannot both become contaminated by smoke. An air release path is then required in the corridor to allow for the air to flow from the lobby into the corridor and providing the 2 meters per second velocity. This can be achieved by ventilators in the facade of the building if they can be positioned in opposite faces of the building to allow for adverse wind pressure. More commonly, it's done through a rising shaft as illustrated here. This can be a natural vent shaft or a mechanical system, which would require an additional set of high temperature extract fans on the roof. Escape travel distances are often extended beyond the recommendations of approved document B using BS 9991 guidance, and travel distances of up to 30 meters are not unusual. The current draft states that where corridors have single direction travel distances exceeding 15 meters, then an additional mechanical ventilation system is required to maintain tenable conditions within the corridor. Here's an illustration of a building with an extended travel distance. Once again, we have a pressurized staircase and lobby and a firefighting lift shaft. In this case, the extended corridor also requires protection. One possible solution would be to make the air release shaft a mechanical dual-purpose air release and smoke extract system with high-temperature fans. At the opposite end of the corridor is a natural ventilation shaft to provide replacement air to the extract system when the lobby door is closed during the means of escape period. And here, for comparison, we see a typical extended corridor smoke control system to current standards. We have a single extract shaft in the lobby and a vent at the head of the stairs that provides replacement air. Comparing this with the previous slide, we can see that there's a considerable increase in the level of equipment and space taken up in the building by the new approach. To give some context to the plant requirements, here's a typical extract fan arrangement that would be mounted on the roof. The overall dimensions would typically be in the region of 3 meters long by 1 meter wide by 1.5 meters high, with something like a 30 amp power supply requirement. A pressurization fan set would be of similar proportions, and the inlet ducts would need to be extended in different directions to prevent smoke contamination. The typical riser duct sizes within the building would be 0.6 meters squared for the stair pressurization, around 0.6 meters squared for the lobby pressurization duct, and the same for the mechanical air release. The natural air supply shaft would need to be at least 1 meter squared. So we can see there's a considerable amount of space taken up within the building for these provisions. For pressurization and mechanical extract systems requiring different fan speeds for means of escape and firefighting conditions, it's been common practice to install fireman switches that require manual intervention to switch the system to high speed when firefighting commences. there's been much debate about the appropriateness of this method and an increase in reluctance by firefighters to agree to the use of such devices. Considering the lack of standardization, labeling, and location of such switches, and the complexity of common smoke control systems these days, this is not surprising. The current draft proposal advises that systems, with the exception of openable vents, should be fully automatic in their operation and should not rely on the interaction of firefighters to achieve their performance objectives during the means of escape or firefighting phases. Smoke control systems should start in firefighting mode at the outset if this is a requirement. Alternatively, variable speed mechanical systems should be controlled using pressure sensors or other means and should not require firefighters to operate controls in order to initiate a high-speed mode. This would entail monitoring the pressure in the lobby and increasing the fan speed when the lobby door is open, which should correspond with the firefighting phase. Natural smoke shafts have widely been used on single-stair high-rise buildings, both for means of escape and firefighting for many years. Their use is now limited to buildings up to 30 meters with multiple staircases and compliant travel distances. So finally, I'd like to look at the changes to multiple stair buildings over 18 meters. Here we still have the option of using natural smoke shafts up to 30 meters or mechanical extract systems for taller buildings. The change will be the addition of lobbies for evacuation lifts or firefighting lifts, and smoke control will be required to protect the staircase and the lobbies. Escape travel is as prescribed in ADB with a maximum dead end of 7.5 meters and 30 meters between connecting doors in the corridors. So the changes contained in this draft make the design and implementation of smoke control systems for most high-rise residential buildings significantly more complex. The detailed design will almost certainly be carried out by a specialist, and selecting a competent one will be even more important in the future. One measure of competence is third-party certification, and we would strongly recommend using a member of the IFC SDI 19 scheme, which is currently the only one for smoke control specialists. It's also important to check the scope of certification, as many scheme members will not be certified for design. A further positive indication of competence is membership of the Smoke Control Association, which in addition to third-party certification, requires minimum levels of PI insurance and adherence to the Code of Conduct, which mandates the use of independently tested products. On the SCA website, you can see members with a table here which details their scope of work. So I would suggest this is a good place to start when looking for a competent contractor. So in summary, we would say the addition of evacuation lift lobbies is the most significant change affecting smoke control provision. And this, combined with the requirement for pressurization systems for single stair buildings over 18 meters, is likely to make them considerably less attractive to developers. It remains to be seen what the final published guidance will look like, but in the meantime, our advice would be to consider pressurization over mechanical extract for single stair buildings at design stage and to engage with a competent specialist early in the design. Thank you for attending today, and I hope you found it useful.